obviously know when we are describing the Boolean function, that time what happens, some particular variables we are using, x1 to xn. Okay, so what happens, a product term, the first point, a product term of all the n literals. That means literals means what? This type of x1, x2 up to xn. Are you getting my point? And this is also called a variable, and this is in the form of n operation. Okay, and the whole thing is called a term. And when this particular term within the variables, when we are considering the term, some particular variables are associated with that particular term, and all the variables are belongs to the n operation. That time what happen? We can say this one is a mean term. Okay, and oppositely, whenever instead of product, if we are using sum term, okay, and we are using the or operation, that time what happen? This one is called a max term. Okay, this one is called a max term, and this one, if we are using the n operation and we are using the product term, that time what happen? This one is called a mean term. So see here, if you are considering the three variables a, b, c, that time what happen? I am giving one particular example of mean term, and this one is called a mean term. Okay, that means what? This is one particular term. Okay, and this is one particular term, and this is one particular term, and all the variables within that particular term and operations are associated. Okay, and similarly, what happens when we are considering the max term? That time what happens? We are using, instead of n operation, we are using the on or operation with that particular literals. Okay, here a bar plus b bar plus c bar, this is called a term of max term. This one is called a term as a max term. But one thing always remember, when I'm using the max term, okay, when I'm using the max term, that time what happen, or mean term, that time what happen, some particular variables are missing. Suppose what happen here is the ABC, instead of ABC, if I'm using only AB and C is missing, that time what happen, this is not a mean term form. Okay, max term means, mean term and max term, we are using all the variables which are associated with the function. Always this particular case is very important. Always we are using f. Okay, so properties of mean terms and max terms, always you remember, a mean terms assume value 1 for exactly one combination of variable. So what happens when the all the values, that means we are using as a logic value 1. Okay, are you getting my point? Logic value 1. And when we are using the max term, that time what happens? Just opposite, we are using the value for exactly one combination of variable. Okay, next, for given a variable function and for a given values of the input variables, that time what happens? If all the mean terms that have value 1, that time what happens? This one is called a true mean term. And all the mean terms that have a value 0, that time what happens? This one is called a false mean term. And same way, if we are considering the max term, that time what happens? If value is 1, that time what happens? This one is called a true max term, and this one is called a false max term. Okay, so suppose I'm using some particular example here, x bar y plus xyz. This is not a mean term form. Why? Can you tell me why this is not a mean term form?
Because what you
yes said. So what happened? Correct. So what happened here? This is the you see the first term x bar y, here z variable is missing, or z literally is missing. Okay, but second mean term it is okay. Okay, it is good. But how that time what happened? How introduce? We can introduce this way: x bar and y, and after that what happened here? Z is missing, so you can just introduce this way: z plus z bar. Okay, and after that what happened? Z plus z bar means what? Z bar, if when we are going to the OR rules, that time z plus z bar equal to 1. So just you can multiply x bar y with z and x bar y with z bar. That time what happened? We are getting all the necessary term. Now if we are writing the expression in this particular format, then it is called a true max term. Sorry, true mean term. Okay, and same way, see here, x plus y, see here, x, if we are writing x plus y, just a minute. Hello, hello. Oh, morning. মই ৰবা, মই তোমাক অকমান পিছত কৰি আছো, মই ক্লাছ এটা কৰি আছো। So how, see here, so here when we are writing xy, see here z also missing. So how can we write this one xy, or you can write right now you are not using this one. Suppose plus we are writing z dot z bar. Okay, z dot z bar, and see here x plus y, so z term is missing. So what we are using now, what happen in distributive law, if we are applying the distributive law, that time we are getting this way, x plus y plus what, tell me, x plus y plus z, this is one particular term we are getting. So all the variables or all the literals are present, and next one is called x plus y plus z bar. Okay, are you getting my point? So this is a distributive law, yes or no?
Yes, sir.
So what happened here? Also you can same way you can do for y plus z. Here x is missing. Just instead of z, you can write x dot x bar. That time what happened? When we are evaluating all the terms, that time what happened? This is the final term circle. Are you getting my point? So this is the all the terms are true max term. Okay, because here we are using what? Here we are using product between the terms. Okay, here we are using the product between the terms here, and after that, whatever all the literals, we are using the sum operation. So if we are writing in this particular form, sorry, here it is not a mean term, here it is max term. Don't use here mean term, here it is a typing mistake. Just you can use the max term. Okay, this way we can evaluate it. So whatever, see here, true mean term means what? Suppose here I'm writing suppose x bar. So x equal to, suppose whatever we are considering as a 0, y equal to 1, z bar equal to 0, then if we are considering x equal to 0, then x complement is 1. Okay, y already 1, and z bar, if we are using z equal to 0, that means z bar equal to 1. So that means what? This one is called true mean term. And some particular mean terms it's occurred in the logic value 0, that time whatever it is called a false mean term. And same way whatever the reverse direction we are called a max term. Okay, but whatever output is value is always produce 1, then it is called a true mean term, and 0 also it is called a false max term. Okay, now see here, this is the Boolean function, but before we are going to the detailed discussion about the Boolean function, some other particular function you have to know, that is called a unit function. What is unit function? A function is said to be unit if no variable, remember, if no variable appears in both complemented and uncomplemented, form. Okay, in the minimized expression, not a normal expression, in the minimized expression. So very carefully you read the definition. Okay, so what do you mean by unit function? Unit function is that a Boolean function is said to be unit if no variable appears in both complement and uncomplement forms in the minimized expression for that particular function. Okay, so normally what happens if we are without minimization, if we are getting this one, then that time what happens, we cannot say that is unit. So after minimizing, if we are getting uncomplement and complement form, that time what happens, we are call a unit function. Suppose we are giving one particular example. See here in this particular expression, see here we are using three variables. One is a, one is b, and another is d. Okay, so what happened here? A is uncomplement form. Okay, and the second term, first term, a is uncomplement form, and b is also uncomplement form. Now see here, second term plus bd. In first term, b is uncomplement form, and as well as the second term also b is uncomplement form. And d we are not using in the first term. So what happened? It is the all the terms are uncomplement form. So this one is the valid unit function. Okay. Suppose second one, can you tell me second one is the unit function or not? सो गए क्या सभी लोग?
No, sir.
Why I'm asking? Why you are so here? Why you are so lazy? रेस्पॉन्सिबल में इतना सारा 22 स्टूडेंट 24 स्टूडेंट को इतना टाइम लगता है? नहीं, दूसरा कुछ काम कर रहे हैं आप लोग? If you have a, if
सर आपका वॉइस लेग कर रहा है.
if you have any problem in the suppose मैं बोल दिया कि सैटरडे को मैं क्लास लूंगा, ऐसा जरूरी नहीं है कि सैटरडे को ही क्लास लेना है. आप लोग का प्रॉब्लम बोलेगा कि सर हम लोग का क्लास है, एग्जाम है, आप थोड़ा टाइम चेंज कर दीजिए, then I will listen to you ना. Okay, so don't, it is not forcefully, I am not taking the class, remember, and it is only for you. So if you are not interested, then it is no meaning. I'm just speaking from my side. It is not a it is not a it is not a learning process actually. What the side it is what the side if it is compromised, then it is okay. Okay, so what my question is that second expression, we are, this is called a unit function. Suppose unit function, suppose I am defining a b d. Okay, and expression is a b bar plus b bar d and plus a d. Now you tell me, this one is the unit function or not?
Not, sir.
Why? Not yet. No, sir. Why? Why is it not a unit function?
Sir, because
Okay,
there is a complement form.
It
No.
consists of both complemented and uncomplemented form.
No. This one is the valid unit function. Now I am giving the justification. See here, first term in the, if we are considering this particular term a b bar, first term, that time what happened? You can see a is appeared in this particular term, and any other term a is appeared. Yes, here a is appeared. Here also a is uncomplement from, and the first term also a is uncomplement from. So and using till now we are not using a letters. Okay, so for a it is okay. And again first term here we are using b complement, but second term also we complement. So it is not like that this one is the b complement and this one is the only b, that means uncomplement. So in first term b also complement from, and second term b also complement from. But in the when we are considering the third term, b is not available. So for b also it is okay. That means this particular complement and uncomplement, these particulars are satisfied. And also you can say see d is present in the second term and d also present in the second term, but these all are the uncomplement form. So what happen, all the variables either it is complement or uncomplement form. So this one is a unit function. Right now you are getting or not?
Yes, sir.
Yes, sir.
Yes, sir.
Now tell me this third one is the unit function or not? A B C
Yes,
bar
sir.
plus A B C.
No, sir. Unit
function.
So it is
No,
not
sir.
a unit function.
No, sir.
Yes, good. So it is not a unit function because here what happened? This one is the C complement, but here is the C. But remember, yes, just a minute. I am completing this one. After that you can ask. So A B C bar plus A B C. This one is obviously C. Here the first term C is the complement from, and second term is a uncomplement from. So this one is not a unit function. But remember, this expression not fulfill the minimized expression, because this one is not a minimized expression, because we can write this way also. A, here we can take the common A B. Okay, after that we are writing C bar. This one is the C bar and this one is the only C. So C bar plus C means what? It is 1. So when we are minimized expression of AB C bar plus ABC is AB. Now this one is the unit function. Are you getting my point?
Yes, sir.
Okay, किसी ने कुछ someone have a doubt? Please ask me.
No, sir. I was going to ask this one only in the minimized form.
Okay. So what happened? So, but this one is not a minimized from second one and first one. So we can evaluate this way. If some particular expression is not a is the minimized from, then at first what happened? What is your duty? At first you minimize at first. After that you can check the definition of unit function. If someone is asking, just you check this one is the unit function or not. Okay. So see here. So based on this particular complement and uncomplement form, we have a two categories. This first point and a first point and second point. A switching function, or you can say Boolean function, is said to be a positive unit if all the variables appeared in the uncomplement form. Suppose what happened? The first one is the positive unit. Are you getting my point? And a switching function is said to be negative unit if all variables appeared in only complement form. So the second one is not a unit, but third one is also not a negative unit or positive unit, because positive and negative complement, complement and uncomplement, all the literals are present. Okay, but you remember in this particular case, minimize expression. Okay, and here also I am writing minimize expression. But remember, some particular function is not satisfy this complement and uncomplement form. That time what happen? This one is called a non-unit. Are you getting my point? So this is the concept of unit function. Now see, uh, sometimes what happen, after all what happen, why we are studying this type of things and all those things, why this actually required? Because what happen, our main target is that we are designing the circuit. So before designing the circuit, what happen, we have some particular objective is there. Objective means what? How we can design the circuit, how design the whatever the inputs we are providing, and what is the output of that particular circuit. So all input and output are actually formed by the Boolean function. And Boolean function, it is nothing about it is the concept of Boolean algebra and some rules we are using. So I have already told what is the advantage when we are minimize the Boolean expression. That time what happen, when your expression is very minimized, from that time what happen, circuit complexity is very less, number of gates also very less. Okay, and easily design, easily understand. So what happen, minimize the Boolean expression is very essential. But remember one thing, when we are writing some particular function, that time what happen, more number of variables, more number of terms and variables are required to satisfy some particular situation. That time what happen, we are writing that particular expression is very lengthy, and when we are going to the simplification or minimize from, that time what happen, our steps is very lengthy. So how we can know, that means which particular term providing what type of values. Okay, so for that particular purpose, if you know already, that means this particular term provide this particular number, that means unique representation, and another particular term of that particular expression provides some other unique value. That time what happen, when we are getting some all other unique value, that time what happen, our expression may be easy for us to design the circuit. Okay, for that particular purpose, what happen, to distinguish which particular terms provide which particular number, unique number or unique representation, for that particular purpose we are using some particular canonical form. So function also, this particular function also we can represent with the help of canonical form. Okay, so always remember, when we are canonical representation, that time what happen, two particular form we are using. One is called a sum of product, and many of the books it is SOP, it is the short form, it is called a SOP. Okay, and product of sum, it is called a POS form. Whatever we are discussing till now, it is not a some particular different type of things, it is whatever we are discussing till now, all the concept we are using in the SOP form and POS form. But remember one thing, SOP form means what? Sum of product, and you already heard about these particular things, some type of normal forms we are using. So when we are using SOP, sum of product, that time what happen, we are using disjunctive normal form. It is also called a one type of disjunctive normal form. And product of sum, also called a conjunctive normal form. Suppose I am giving one example of sum of product. Suppose A, if we are writing A, B plus B bar, and C. So this is the valid sum of product, because what happened, this is the term, all the terms are associated with sum, and also this is the one type of form of disjunctive normal form. And same thing if you are writing A this way, A plus, okay, A plus B, and after that we are using product term. Okay, and we are writing here, suppose B bar plus C. That time what happened, this one is called a product of sum. Why it is product of sum? Between the term we are using the product operation. Are you getting my point? But when we are writing in between the literals, that time what happened, we are using the OR operation. Okay, so this is the one type of form of product of sum, and this one is the AB plus B bar C. This one is the sum of product. Are you getting my point? So now how we can represent the sum of products, sub form. Okay, here I am using some particular truth table, and truth table is coming from any particular year. Any particular truth table is the behavior. That means what type of behavior actually present. So what happen when suppose if we are writing some particular, how we can from the truth table, how we can define, we are defining some particular function, and this particular function, how many variables we are using? Two variables we are using. Sorry, three variables we are using. One is A, B, and C. Are you getting my point? So C. So three variable we are using. And what are the outputs? Suppose we are considering F1 and F2 is the output. Now what happens when we are talking about the soft form? Soft is nothing but a sum of product. Okay. When we are considering the sum of product, how we can generate the expression for this particular function. Okay. So what happens? See here how we can write this one. Suppose what happens, we are interested to find out the expression for here two functions are there. Sorry, two outputs are there. One is F1 and other is F2. Okay. So what happens if I'm writing for F1 and this particular expression we are writing in the soft form, that time what happens according to the definition of soft form. Soft form actually directly connected with the mean terms. Okay. So mean terms means what? Here some particular true mean terms are there, and here some particular false mean terms are there. And when we are using the soft form, always we are using the concept of mean terms. Okay. Now see here when we are writing F1. So if we are this particular sequence, if we are applying this particular sequence, then what is the output? Output is 0. F1 is 0. And when we are using this particular 0, 1, 1, then also it is 0. Okay, something like that. But when we are writing the expression, we are always consider the output value where the logic value is 1. So 0 we are not considering, but this one is 1, so we are considering. This one is 1, so we are considering A, B, C bar. Sorry, 0, 0, 1. So this is the sequence 0, 0, 1. But when we are writing in the form of expression, that time see here, because we are using the mean term, so for this 0, 0, 1, we can writing A bar, B bar, and C. Now you ask me why we are using A bar, why we are not writing A? Because what happened according to the mean terms, the definition of mean terms, that time what happened? 0 means false value. And false value when we are writing in the mean terms from, that time what happened? This one is the complement. Okay, here this particular F1 is 1. Which particular sequence? 0, 0, 1. So where A value is 0, so here we are writing A bar. B value is 0, here we are writing B bar. But C value is 1, so we are writing only C. Now what happened? This is not a complete. After that what happened? Because we are writing in the soft form, so this one is the plus. This one is what? This one is the plus. Okay. Next, where 1 is appeared, here 1 is appeared. So this one is what? 0, 1, 0. 0, 1, 0 means what? 0 means A bar, here A bar, B, and this one is C bar. If you are not getting, if any doubt, please ask me, don't hesitate. Okay. Next one is what? 1. Okay, because we are not considering this one, because this one is the 0. Okay, so we are not considering this particular input binary sequence. Now what happened? F1 is 1, that time what happened? 1, 0, 0. 1 means what? We are considering here it is A and B bar, because B also 0, and this one is C bar. Okay, next one is where it is 1? This one is 1. This one is 1. Okay, so what happened? We are considering this particular sequence, so we can write plus, we can write A, B, and C, because all are 1. But remember, F1 is not a, we don't know, this one is the minimized form or not. We don't know. If we are simplified, then we can do. So simplify means what? You can use the one particular technique for simplification or reducing the function is that you can apply the standard rule or laws. Okay, whatever we have discussed already. Okay, after that, from that, if you are getting some particular expression, that time whatever, this one is the minimized form. Okay, but maximum minimized form you have to consider. Okay, so same way if you are writing F2, then F2 also when we are considering this one 1, that time what happened? Because all are 0, so here F2 output is A bar B C. When we are considering 1, that time what happened? A B bar C. And when we are considering 1, that time what happened? We are considering A B C bar. And when we are considering 1, then also again A B C. This way we can writing the sub. Now see here, when we are getting, suppose I am considering F1, when we are considering the sub form or sum of product, that time what happened? This particular expression generates some particular unique value or unique representation. How we can assign that particular unique representation? Always you can use some particular book, they are using only summation symbol. And some particular book also they are using M, subscript of M, small letter M. Okay. So you can use both. If you are using only summation, then it is also correct. If you are using this summation and subscript as a M, small letter M, then also it is correct. So that means what? This is the notation we are using the mean terms or sum of product. Are you getting my point? So see here, what is the sum of product? A bar, B bar, C. So 0, 0, 1 means what? This one is 1. You can just, mean terms always we are writing in the number form, not a decimal number form, only we are considering the integer number form. Okay. Second one is what? A bar, B, C bar. So 0, 1, 0. 0, 1, 0 means what? 0, 1, 0 means 2. Next one is, see here. Next one is what? A, B bar, C bar. That means what? 1, 0, 0. 1, 0, 0 means what? 4. Yes or no? And another one is what? A, B, C. A, B, C means what? Here this one is 7. So this is the unique representation of mean terms, and which is this particular mean terms are coming from the sub expression, and this one is called as what? Same way we can write for F2. So F2 what? This one is 0, 1, 1, 3, and this one is suppose 1, 0, 1, 3, 5, 3, 5, 6, 7. So this one is for F1, this one is for F1, okay, and another one is for F2. This way we can represent the mean terms. And always remember, when we are using the mean terms, always we are using the summation symbol. Okay. Next one, product of sum. So when we are using the product of sums, that time what when we are using the concept of max term. Okay, so max term means what? See here, always we are using the reverse operation or reverse concept we are using for max term. Okay, so suppose mean term we are using only when the output is 1, that time what when we are considering the input binary sequence. But when we are considering the product of sum, that time what when we are considering not on no, we are not considering 1 logic value 1 as a output. We are considering only 0. So see here how we can write. So F1, the same table, same truth table, if you are writing in the F1. So see here F1 how we can get this particular value. Okay. Sorry, this one, sorry here. Suppose here we are writing. So 0, 0. Okay. 0, 0 means considered because we are using product of sum. We are not considering 1. We are considering only 0. Okay. What is the binary sequence? A, B, 0, 0, 0. So that time whatever how we can write? In mean terms, 0 means what? A bar. But when we are considering max terms, that time whatever we can write? What we are writing? We are writing A bar, A plus B plus C. After that, because we are using the post from, so after that, where is the 0? This one is the 0. Okay. So what happened here? We are writing A plus B bar plus C bar. Okay. After that, again we are using the product term, and next term is what? This one is 0. Okay. So what happened here? What we are writing here? A bar plus B plus C bar. Yes or no?
Yes, sir.
Yes, sir.
And last one is 0. This one we are writing. Can you tell me what is the term?
So A bar, B bar, C. B bar,
A
C.
bar, A bar
Correct.
plus B bar plus C.
Yes, correct. A bar plus B bar plus C.
C.
Okay, are you getting my point? So what happens? This one is the whole product of sum. And always remember, when we are considering the product of sum, that time we are using the concept of max term. Now what happens if you are representing the unique number, okay, of this particular expression, and when we are using the post, not a sub, product of sum, that time what happens? We are using this particular symbol, the big pi. Okay, some particular book also may subscript considering as a capital letter M. So this way you can write, or if you are writing only single pi, then also it is no problem. So in this particular expression, what is the pi? A, B, C. A, B, C means what? This one is all are 0. So this one is 0. Are you getting my point? So next one is what? Next one is 0, 1, 1. That means A is 0, B bar is 1, and C bar is 1. Are you getting my point? 0, 1, 1 means what? It is 3. Next one is A bar plus B bar C. A bar plus B bar C means what? 1, 0, 1. 1, 0, 1 means what? 5. And next one is what? A bar, B bar, and C. That means what? 1, 1, 0. So this one is 6. So this way we can represent the product of sum and sum of product. Okay. And why this particular number is required? Why representing in why unique number is required? That particular part I will discuss later. And how we can use in the digital when we are constructing the digital circuit. That time also you know, because without knowing this particular concept, you cannot, because some particular expression or some particular function we are defining with the help of this particular only. So whatever you have to know when we are considering pi m, that time what is the expression actually? This when we are writing this one, pi m 0356, automatically you know that indirectly this particular expression is associated with this particular unique number.
Sir,
Okay.
sir,
Yes. Yes.
I have a doubt, sir. The last term A bar plus B bar plus C, how it will be 110? Sir, in the B it is already 1 from the
No.
table.
B is already 1. Yes, B is already 1. So what happened?
Then,
see here, when we are writing in the sub form, are you getting my
yes,
point?
sir. Yes,
When we are writing the sub form, that time what happened? You always remember when the logic value 0 means what? It is the complement form.
yes, sir.
Okay, this is the complement form. Okay, complement form. And 1 means what? 1 means uncomplement form,
Yes, sir.
according to the definition of mean terms. Okay, it is the uncomplement form. Okay, but when you are writing in the post form, that time what happened? 0 means what? Just opposite. 0 means uncomplement form,
Uncomplement.
and 1 is complement form. Okay, so 0 is
Yes.
uncomplement form. You are considering the last term. So 1 means what? 1 means uncomplement form.
One means uncomplement. Complement.
Complement form. So here we are writing a bar. Okay,
Yes, sir.
again 1 means what? We are considering not a sub, we are considering pos. Okay, so 1
Yes,
means what? It is the complement form, and 0 means uncomplement form. So 0 means what? This particular 0 is associated this particular variable C. So here I am writing here C. Are you getting my point?
Okay, sir. Yes, sir.
So 1 means what? It is the value of B. So here I am writing B bar. This way we can generate it, but generating the number we can consider that this. What is the numbering? This one is called a 0. This one is called a 1. So we are maintaining the binary sequence 2, something like that, and up to dot up to what? Up to it is 7. So see here it is clearly defined A plus B plus C. That means A plus B plus C is what? 0. So 0 is coming here. And 3, which one is the 3? 0, 1, 1. So it is 0 here. F1 is 0. So this one is 3. Something like that. Are you getting my point? So
Yes,
soft
sir.
means what? Always remember, when we are using sum of product and when we are defining this type of unique number representation, always remember, when we are using soft sum of product, 0 is complement from, 1 is uncomplement from. And when we are using post from, it is vice versa. That means vice versa. That means 0 is uncomplement from and 1 is complement. Okay. And this is the representation of product of sum, because in between we are using the sum operation, but within the term we are using the product operation. So it is called a product of sum. But when we are using the sum of product, that time what happen? Sum of product, that time what happen? We are using within the term we are using the n operation within the term. Whatever the variable or whatever the literal we are using, that is all the literals are associated with the n operation. But when we are considering between the term, this is one particular term and this is one particular term, that time what happen? We are using only or operation. So it is called a sum of product. Are you getting my point?
Yes, sir.
Yes, sir.
Okay. So you just study, you can study through a textbook, then just you can study what is the canonical form, what is the sum of product, product of sum, and some particular examples. Just you can take the definition, just study the definition. No need to right now, no need to. You can see, no problem. You can see the example also, but a lot of examples are there. So next class we will discuss about the example, how we can use this one. For the time being, you just say that means what is the unit function, what type of canonical forms are there, what is the mean of exactly meaning of mean terms and max terms, because mean term and max term directly related with SOP and POS. So if you don't know about the mean term and max term, you cannot go for SOP and POS. So hopefully whatever I'm discussing right now, from this particular discussion, you are able to understand what is mean term, max term, or something like that, sum of product or product of sum. Okay. Next, because I'm not taking too much time, because from the 11 you have a class. Okay. So you have a class. Exam. So just I'm. Yeah. Pardon? Yes. Pardon? Yes.
So exam, sir, exam.
So, okay, no problem. So I'm here. So today I'm complete my class before 10 minutes. So such that you can prepare your exam. Okay, no problem. So next class we are discussing the other parts which are related of these particular things. Okay, next class we will see this. Okay, you can just a minute. So you can leave.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.